Hello everyone and welcome to Growing in Investigation 5, Problem 5.1. Today's ACES questions will be number 1, 67 through 69, and 82 through 90. So as we get going in Investigation 5 here, and we take a look on page 76 of your textbook, we're going to be getting into patterns with exponents. And we made a table when we were working in investigation 2 that involved having the growth factor of 2 and filling it into different exponents of n. Well, our table begins to show patterns, and that's what we're looking for right now is patterns. And here it says that Roxanne noticed in each of the products below the sum of the exponents of all the factors is the exponent for the product, meaning that whatever 2 to the first is, so 2 to the first is up here, is 2, times 2 to the second, which is 4, so 2 times 4 equals 8, should equal 2 to the third. Well, 2 to the third is 8. Also, 2 to the second, 4, times 2 to the third, 8, or 32, is equaling 2 to the fifth, which it does. So the question is, when we multiply any of these two together, is it the same product as if we added these two exponents together as long as we have this same base? So that's one of the patterns we want to take a look at, one of the rules we're going to learn about here in this investigation. But it asks here, is Roxanne correct? Explain why or why not. And does Roxanne's pattern hold for any number b, as in b to the second times b to the third? Well, let's try it out for, we'll say 3, okay, for a growth factor of 3. So we'll say we have 3 to the second, okay, oops, that's a second. Again, I'm doing this right-handed as a lefty, so be patient. 3 to the second, that's an interesting looking 3. 3 to the second times 3 to the third, they're saying should be 3 to the fifth. Okay? Well, 3 to the second is 3 times 3, or 9, times 3 to the third, which would be 27. Okay? Oops. This shouldn't be equals. Okay? Let's just go ahead and get rid of that. Sometimes we can just do better, can't we? So 9 times 27 equals, we've got 9, 3, carry the 6, 18, 243, I think, ish, seems to me. Should equal 3 to the fifth. Well, 3 times 3 times 3 is 27, we've already determined, right, from the one above. So that equals 27. And then we need to have 27 times 3 equals 81, and then times 3 for the fifth time, and that does equal 243. Okay, 81 times 3 does equal 243. So these two are equal. So that might go into helping you to find some patterns. So as we look at 5.1, our learning target is to begin to see patterns and lay the groundwork for properties that we're going to start putting down tomorrow. We're gonna learn some rules about exponents, but hopefully we can find some patterns today that will help guide us in setting the groundwork for those rules. So in 5.1 on page 77, the values of a to the x for a given number a are called powers of a. We just looked at situations involving powers of 2. Problem 5.1, we're going to explore powers of 2 and other numbers. So I'm going to go ahead and pause my video here so that I can break it up to get all the files uploaded. I'll be back with you momentarily. Okay, what we're going to be doing here is in this table is on the left-hand side here, these are your exponents. And along the top are the bases. So we are taking the base of 1 and raising it to this exponent. So 1 to the first is 1. 2 to the first would be 2. Therefore, 3 to the first is going to be what? Yeah, 3. 3. Okay? 4 to the first, 4, so on and so forth, okay? And then as we go down, we have 3 to the second, and that's going to be 9, okay? 4 to the second would be 16, okay? So you're going to continue to fill out this table of having your base raised to your exponent. 3 to the third, 27, okay? So hopefully you see how this is going. I think it would be a good idea if you went ahead and filled out this table before class, so you had this ready to go to discuss with your teammates when you get into class tomorrow. Part B says, describe any patterns that you see in the rows and columns and give examples of those and explain how you know you're correct. So I'm not looking for any specific patterns. I just want you to be able to take a look at your table and say, hey, I think this happens if you do this, or I see this happening here, and just be ready to explain that to your teammates so you can come up with some ideas. Then part C, this is where it gets a little trickier. It says Delmar noticed that if you extend the pattern upwards in the table for negative values of x, you get the values shown at the right. And it says copy the table and extend it to include columns for 3x through 10x, meaning if we draw this out, and that we would have this, and you'd be making columns like this would be for 3 to the x all the way out here to eventually you'd get to 10 to the x. So draw your table out like that. So we found out one of our rules earlier is that any base raised to the exponent of 0 is going to wind up being 1. So this is going to be 1 all the way across to here. Then on the next one, we have a negative 1. Okay? And what happens when we have an exponent that's a negative, what we have to do is invert and raise to the power. So this, when we have 3 to the negative 1, okay, what we really have is 1 over 3 to the first. Okay, so that's going to be 1/3. On the second one, we have 3 to the negative 2, and that's going to equal 1 over 3 to the second power, which is 1/9. Okay, so hopefully you see how that's going. Go ahead and finish the whole table doing that. We're only going up to a -2, no further than that. So that's what we need to be doing in our class discussion. If you want to work on this table too before you get into class, that'll save you some time to give you more time to do your ACES assignment in class. Speaking of ACES, here we are with 5.1, our ACES number 1, 67 through 69, and 82 through 90. Hopefully this will be able to guide you to get started on these and have good discussions in class. I look forward to your questions.